So the next speaker is Jens Fischer. He's from the Federal Maritime and Hydrographic Agency in Hamburg, Germany. And you will address measurements, Jens. The floor is yours.
Yeah, good morning. Good morning. Yeah, as you said, my name is Jens Fischer. I'm from the Federal Maritime and Hydrographic Agency, the BSH in Germany. Together with my two colleagues, Fritjof and Dennis, we're coordinating the measurement and data management work package. And I try to give you today a short, very brief overview about these work package and the work that has been done in this work package. So what are the objective of a work package that's called measurements and data management? Of course, it is doing measurements. And so the main objective of the work package in the JOMOPANS project is to develop an ambient noise monitoring concept for measure underwater sound in the North Sea for 1 year with the aim to collect the data, to process the data, and to provide this data for the validation work for the comparison between the model and the measurement results. I divided here, or I would highlight it, two main work areas here. Of course, we will talk about measurements, we will talk about data processing, and we will talk about the data management and sharing opportunities that we are developed in the project. Here on the map, you could see the green shaded area. This is a specified project area where we carry out our measurements. And you could see the colored markers here, which represents the different measurement stations in the JOMOPANS project. At the start of the project, we have originally planned with 9 different stations. During the project, the amount of station numbers extend, and in the end, we are ended about at 15 locations where we measure underwater sound for 1 year. But in the very end, we ended up with 18 stations because there are a lot of attentional stations where we have snapshot measurements, campaign measurements at specific locations. So 18 stations against the planned 9 stations. I think that's a very good result. Involved in these measurements are all members, all partners in the project. So we measure in 9 different EEZs. The selection of the location based mainly on past experience of all project partner, of course also on logistical opportunities and also on feedback of the modeling group. We have a colorful bunch of different locations with different acoustic characteristics. We have stations that are located relatively near at shipping lanes where ship sounds dominate. We have stations that are far away from shipping lanes, so environmental sounds dominates here. We measure near wind farms, we measure near ports. So we have a lot of different station characteristics, so that I think it's a good data set to test and validate the model results. In the project, we have no strong requirements for the use of any systems. So we have carried out the measurement in the JOMOPANS with a variety of different setups and hydrophones. Here on the pictures, you could see the different hydrophones and the different setups. In general, we follow two simple setups. We have an measurement system which is located at the C button. Then we're using some recorders and hydrophones to collect the data. The other system is nearly similar. It's more in a metal frame rig system. So it's also located at the C button, and the measurement take place about 2 to 3 meters above the C button. We have two systems of recording methods used here in the project. 4 of these 18 stations are cable-connected stations. So you could both systems has advantages and disadvantages. I think for the cable-connected system, it's relatively obvious. You could clearly see when you deploy the system, is it working? So when you're measuring autonomous, you carry out your system and you see after your measurement phase, is it working? So, but both system has advantages and disadvantages, and we all bring these together in the report, in the concept we right. So you could take a look on these to get more details on these. Of course, when you measure data, you are collecting, especially when you're collecting underwater sound data, you got a lot of data, and you have to process these data. You have to quality control your data, and you have to fit your data so that sharing is possible. I don't want to talk here in detail about the processing methods, because this is a subject of the next speaker, but the work of the processing will be also the work here in work package 5. What I would like to highlight here is that we're creating a data format in JOMOPANS project data format in the project, so that we are able to share the data in a comparable way. And this data format could also be used as a starting point for further discussions, maybe after the project, when we are talking about questions about how we could store data, how we could share data in the future. So for us, this data format is a very important result here also in the project. Offshore conditions. I think many of you know what it means when you want to measure at sea, especially when you want to measure at the North Sea. The North Sea is very high dynamic and harsh and rough marine environment, and so you have to tackle a lot of challenges when you're measuring outside. We have the tidal system, we have a strong wind and currents which impact the measurement, especially when you measure underwater sound. You get some unwanted signals. So it's a very challenging task to measure there outside, but you will see on the next slide, when I show you the data availability charts of our measurement campaign, you will see I think we've done a good job here. Yeah, it's not normal that we get such kind of data for a 1 year period of measurement. So you will see we done it very good. Yeah. So here is the data availability chart. You see a lot of green input here. So we created and I think a unique data set here for the validation work we will see later. So to conclude it here, the main results of these work package work is we have implemented a continuous acoustic measurement program for 1 year in the project. We process this data, we format this data, and we share this data with the group for the further work. So I said in the beginning that we from the BSH coordinating these work package, but I want to highlight and want to mention all partners, because, as I said, every partner are involved in the measurements group, so all results are more a joint result here. So I would like to say, or use this presentation also to say official thank you to the Work Package 5 groups. This was a lot of work. This was a lot of fun, and I think we learned a lot from each other. And I think also when the project will be over, we will stay in contact and exchange information. So for me, this is also an on top result that some new network was established during the project from people that are measuring underwater sound. So I think I'm on the end of the slide. So here, just some impressions from our work so that you could see that in JOMOPANS also some technical work was done. So I tried to find an overview of a picture of all partners to show you that also offshore works is done here in the project. Yeah, thank you very much.
Thank you very much, Jens. It was a very nice overview. And with the last slide, we all get a little bit of a salt taste in our mouth. Thank you very much for that. Are there any questions, Barry?
I have a question.
Niels, go ahead.
Okay, Jens, there's a question. I got a lot of questions. This question I've got a number of times, and it's a little bit light-footed, but the map, our iconic map of the North Sea, with all the measurement stations, and you can see it over there on the bottom side, that green iconic map. Why is it green? Because usually people relate sea with blue and land with green. So here it's reversed, and I like that map, but why is it?
I play a little around with colors, but I think the main target is to achieve some kind of good environmental status. And for me, a good environmental status is more and more on the green color side. So I try to maybe look a little bit in the future and make this area a little bit more greener. So.
Okay, thank you.
Are there any more, Barry, from the chat?
Yes, Jens, we have 3 questions on the chat. The first one came from Soledad. Did you face flow noise problems in places with strong currents? And if so, how did you deal with that?
Yeah, we have some stations where flow noise is occurred, and we see that especially in the lower frequency, we could see that their flow noise occurred. We not finally tackle this problem, but we give some advice in our concept how you could avoid such kind of unwanted noise. And we highlighted also this problem because it's a tidal area of the North Sea, so there the problem occurs. So we highlighted this object for the possible extension to look deeper in these flow noise issues and to develop some kind of quality checks or quality routines to check if there's flow noise and how we could handle this.
Thanks, Jens. There's another question from Gary. How does the JOMOPANS data format compare to other standard formats?
Yeah. So we creating this JOMOPANS format, and we are already in close contact with the sister project Jonas. We are in close contact with the ISIS working group, doing a lot of work for an HELCOM database. So we're in contact with this with the appropriate institutions to highlight our format to support our ideas and we also see that this data format is a good starting point for further discussion on the data storage after the project. So.
Okay, Gary, I hope that answers your question. And there was a question from Paula. Do the data that you collected also include the effect of water characteristics and tide level on the noise level measured?
We also had at selected station, not on all stations, oceanographic meter data, and so you could compare these data with your acoustic data.
Yeah. Okay, that's all.
Okay, thank you very much, Jens. Thank you, people in the chat for the questions.